Maybe, Mr. Kramer, maybe the other people should rewatch our film with the tower, so they'll be up to speed on everything.
Yeah, well, they can.
All the vibes.
Alright,
All the vibes.
moving into section B.
The missing vibes. What? I'm gonna use green. What?
What? This should be review, actually. It was a long time ago. It was probably in the first chapter we did together. Do you guys remember the difference between a chemical change and a physical change? And we had to identify if it was a chemical change or if it was a physical change. You guys know what was the main way to distinguish whether it was a chemical change or a physical change? Moira?
If a chemical changes change what it ends up being, like the final, like the actual element it is. So in physical change, it just becomes smaller or bigger, but it stays the same compound,
So,
whatever.
the difference between chemical and physical change is really this. Chemical change changes its identity. Physical change stays the same, just changes the property. So let me give you an example, see if you can determine whether it's a chemical or physical change. Water boiling.
Physical.
It's physical. Why?
It's not changing, it's still
Because
water.
you're saying when you boil water, it's still water?
Yeah.
How about cut paper?
Physical.
Physical. How about dissolving salt?
Still salt.
Still salt.
Water.
Still water. Physical. Okay? So, chemical change is the result of atoms rearranging to form a completely new substance. I mean, this is probably obvious to you, but just in case it's not, when a chemical change occurs, the atoms are not destroyed. So there's a chemical equation up there. Stuff we're going to do today. We're going to come up with chemical equations on our own. So if I were to do the Lewis structure of these, it's been a while since we've done Lewis structures, but there's a Lewis structure of hydrogen. Look familiar? structure of oxygen. Look familiar? And here's the Lewis structure of water. Look familiar? Okay? When a chemical reaction happens, what you're doing is you're breaking the bonds of your reactants, and I'll explain what a reactant is. It's really just the things that are reacting. These bonds have to be broken in order for these bonds to form, right? Last time I checked, there was no oxygen-hydrogen bond over here, is there? No, so in order to produce water, I have to break these bonds. So all chemical reactions involve 3 steps. Step 1, bonds of reactants must be broken. Right? Step 2, your atoms that are now alone rearrange. Step 3, new bonds are formed. Every chemical reaction has that process. Bonds broken, atoms rearrange, bonds form. Reactants react to produce products. Okay? I want you to highlight, circle, underline that word. Okay, it says signs that a chemical reaction may have occurred. Here are some things that are usually indicators that a chemical reaction has occurred, but not always. Okay? Number 1, solid separates from a liquid. Like if I dissolve something or I had some solid come out of solution. Now, this is sometimes an indication of a chemical change, but not always. Let me give you an example of when it's not a chemical change. If I dissolve salt, evaporate off the water, and the salt comes out, is that a chemical change? No. But if I mix 2 liquids, and the things from both liquids form a reaction and causes something to precipitate out or fall out of solution, that is a chemical change. Okay, so it says may, it's important. Gas is produced. Not always does gas produce mean that it's going to be a chemical change. However, a lot of times it does. Ever seen baking soda and vinegar react? No? You see bubbles, don't you? Yeah. That's because hydrogen gas is being produced. Okay? Color change. Sometimes it also results or is an indicator that a chemical reaction has occurred, but not always. If you put food coloring in water, do you think it's a chemical reaction? So, if those are all those things could really go either way and may result in a chemical change. What is the only way to know for sure that a chemical change has happened? The only way to guarantee is how? If you were to underline anything up there of that phrase or that sentence, what would you underline of importance? New substance. Why? Why would you underline new substance as the important words up here? Yeah? Yeah, it's the only way to guarantee a chemical change has occurred. Only way. Alright. Still writing? Everybody else good? Everett, get it? Alright. Let's get to the real stuff here in a sec. What is it? Okay. Easy one. What is it? A couple more slides and we'll get to the meat of the lesson here. We're about to write chemical equations from the word equations. Start today by writing equations. Then next week we will balance equations. And writing the equations and balancing the equations will probably be like an 8-point problem on a test. There'll be a good amount of them too. And you can't write the equation if you don't know how to write the formulas. You can't balance the equation if you don't know how to write the formulas. So how important was writing and naming formulas that we did way back before Christmas break and spent 2 days to review the past 2 days? Alrighty. There you go. Put it in. Common symbols you're going to see in our chemical equation. I don't know if you guys can see that well or not. Thanks a lot. Sorry. We will use all of those except for, I don't know, I probably could have left out the third bullet there. We probably won't ever use that. We take chemistry, we will. But everything else up there we're going to use, so we need to be able to know what they each represent. Shake off the hand a few times. Crack the knuckles. I don't want to start talking about this until we're all done here. You guys are doing good. Being very productive today. Good job. Some of this stuff is self-explanatory, other things maybe not so much. Faster writers than others. It's okay. When you take my umbrella classes, guess what? I give you notes. Okay? Let's talk about this. Plus sign. You're going to see it in a chemical equation. It's what separates a reactant from another reactant, or a product from another product. It's the big stop symbol, if you will. If you look up here, you see a plus sign here. What that does is it separates my hydrogen gas from my oxygen gas. So that when I mess with the hydrogen gas, it doesn't mess with the oxygen gas. They're two completely separate things. Okay? Now I don't have a plus sign on the product side. Maybe I should slow down. I haven't really defined this. I don't know if you know this or not. This is your reactant side of the equation. You may have gotten that. These are your products. So the left side is your reactants, the right side is your products. And it really is what it sounds like. Reactants do what? React, and products are produced. Make sense? Pretty self-explanatory. Okay? And I don't have another product up here, so I don't have a plus sign. But had I had two products or three products, I would have to have 3 plus signs to separate them, or 2 plus signs or 1 plus sign. Make sense? Okay? And it'll make more sense when we balance. You don't know what these 2's are for or what they represent, but this plus sign says that this 2 does not have anything to do with that. It's a big stop sign, if you will. Okay? And we'll get into that as we progress. Arrow. It always separates your reactants from your products. Alright, have I separated my reactants and products with an arrow? Absolutely. Now I did not put S, L, or G or anything up here, and I probably should have. It could kill somebody. Okay? Believe it or not, it can. That's why it's important. What do you think a G means if I were to put H2 followed by a G? What is that telling me? That is hydrogen gas. And the reason why that could kill somebody, if you don't show that, and they assume it's liquid instead of gas, and it causes an explosion because of how liquids react differently than gases, big deal, isn't it? Okay? Very important. Okay? This just means it's a solid. This means it's a liquid. This is one you're probably not familiar with. It's called aqueous. What it simply means is it's something has been dissolved in water. So if I were to take salt and dissolve it in water, my equation would have to have salt as aqueous to tell me that it was dissolved in water. Make sense? Right. Write this down. This is what you guys will be doing. This first one will be relatively easy. They will get more challenging as we progress. When you take regular chemistry and we add polyatomic ions, then it gets even more challenging. And this is going to be similar to when you guys were naming guys, you didn't know how to put the IDE. Do I do phosphide? Do I do phosphoride? Do I do hydride or do a hydronide? How do I put that? It's going to be similar with this. You'll get a feel as you do more and we practice more on these things. So you will make a few mistakes early on, but that's okay. Cool? Ready? Alright, let's do it. What we will have to do and what your homework is, you'll be doing 7 of these in your homework. Okay? You're going to take the word equation and you're going to write the chemical equation out. Which means you need to know how to do formulas, doesn't it? First one's fairly easy because we're mostly dealing with things we know or things that are covalent. Ionic is when they become a little bit more challenging, where I see most of the mistakes are done when an equation is ionic. Okay? So it says liquid tricarbon octahydride reacts with oxygen gas to produce gaseous carbon dioxide and liquid water. I would just start at the very beginning. What is the very first thing it gives me? Tricarbon octahydride. What is that going to be? That's not too difficult because I think covalents are the easiest one to write. There's one other thing I need to put with this. Liquid. Okay. You'll get the feel of what some of these words mean. What do you think this with tells you you need to do? Plus sign. Make sense? And it says oxygen gas. Okay, oxygen, oxygen, oxygen. So this with the G. I want you to put an asterisk, something beside this, and I'm going to show you something that's very, 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 very important. You're going to have to remember. Do you remember how many times I went over the diatomic elements? I probably said the diatomic elements 50 times. What are the diatomic elements? The 7-on-7 rule. The reason why I kept talking about the diatomic elements is because if you write it like this, it's wrong. It's supposed to be what? O2, because oxygen is one of the diatomic elements. It's in the 7-on-7 rule. Now, do you remember when you specifically have to think about diatomic elements? If it's an element that is alone. For example, H2O, water, right? Those are technically both considered diatomic elements, right? So why isn't it an H2O2? Well, this is not an element. That is a compound. What's the difference? Compound is two or more elements together. So, I don't know if you need to write this down somewhere or something, but what you need to be able to know is if an element is by itself, and when I say by itself, I'm referring to nothing else is with it. You must ask yourself, is it diatomic or not? If it's diatomic, what do you have to do? Put a 2 with it. Here's an example of when you wouldn't. What if it said like solid iron? That's by itself. But is it diatomic? No. So you would just have one Fe. And here's why this is the way that this is. The diatomic elements do not exist in nature by themselves as one. It's not possible. Iron can exist as lone atoms. It is possible. Does that make sense? Okay? So if you do not recognize what the diatomic elements are and put a 2 with the diatomic elements when they're alone, are you going to be able to get this right? And later on, we'll have to balance it. And if you get that wrong, you can't balance it either. It's impossible. Okay? Very important. Okay? Then it says to produce. What do you think that is representing? Your arrow. Okay? To produce gaseous carbon dioxide. We're probably pretty familiar with carbon dioxide, aren't we? What is it? CO2. I mean, you can actually do what it is, right? But I'm sure you guys are familiar with CO2, right? Carbon dioxide. Gas. You guys know what water is, right? Right? What is the and representing? Plus sign. Here's why this is important, because if there's no and there, wouldn't it be like, I don't want you doing this? Right? Does that make sense? Okay? And what did I got to do to finish that? Liquid. Hard? That one was an easy one. Not too bad? Okay. Now, we'll get to this later. This will be a different day. But notice, if you look at the left side, how many carbons do I have on the left side? 3. How many do I have on the right side? 1. Uh-oh. Play God here, everybody. We just destroyed matter. Last time I checked, we can't do that. Not possible. Okay? So we will balance this at a different date, but it is not balanced now. So don't worry about balancing anything at this point. Just write the equation. Okay? No, don't write this. I'm going to change it. I'm going to change it because this one is too easy. This will make it harder. I don't know why I just didn't do this. Got it? Ready to go?
Yeah.
Alright. So here's my first guy I gotta write the formula of, yeah? Okay, so let's see, we got calcium Ca, chlorine Cl, and it's a solid. We good?
No.
Why not?
Ionic.
Oh, so, oh, duh. This is the number one mistake students make. Right here. You wanna know what number two mistake is? Diatomic elements. These are it. Because for whatever reason, students just decide to throw out the rules of how to do formulas completely out the window. This is ionic. There's a rule for that, isn't there? What is the rule? Crisscross method, right? Which means I gotta find the what first? Oxidation number. So we're gonna go over to the periodic table, find the calcium is what?
2.
Plus. Chlorine is? 1 minus, and then what do we do with it?
Crisscross.
Bring them down. So the 2 comes here, the 1 goes here, but I don't write it, correct?
Yes.
Is that going to affect whether you can balance it later on?
Yeah.
Okay, reacts with, what does that represent?
Plus.
Fluorine gas. So here we go, got a little fluorine here.
Yeah.
Anything I should make note of? It's diatomic. And the only reason I need to figure out if it's diatomic is because it is what? Not gas. Why do you have to look to see if it's diatomic? It's alone. These are not alone. This is alone. It is diatomic because it is in the 7-on-7 rule. And then say what?
Yeah.
Okay, to produce. All right, now we got solid calcium fluoride. Is this covalent or ionic? Ionic, metal or non-metal? So we need the what method? Calcium, fluorine, 2 plus, 1 minus, right? Crisscross them down. Voila, voila, no right to ones. I'm just going to eliminate that so it looks nice. And anything else I'm missing?
No, wait, solid.
Solid. And chlorine gas, so we'll plop a little chlorine there and call it gas. Sound good?
It's diatomic.
Why is it diatomic?
It's alone.
Oh, it's alone, it's in the 7-on-7 rule. It's possible that if I gave this to you on a test, you would forget the ionic crisscross method, so you just put CaCl. You would forget that this is diatomic, you would just put F. You would forget that this is ionic crisscross method, you just put CaF. And you would forget that that's diatomic, which means you would do it all wrong on an 8-point problem. Yeah, we didn't even talk about balancing. Okay, questions before we move on? You with me there, Johnny?
Yeah.
Woo-wee. We got some transition elements in here now. Woo! Woo! He even threw in a polyatomic ion, although I did give it to you. Woo! Yeah, you guys don't know what hydroxide is. It's a polyatomic ion that I will make you memorize when you take chemistry. It gets more difficult when you have to deal with polyatomic ions. So I'm just giving it to you here instead of making you memorize the 9 polyatomic ions of the 400 that there are. Got it? Ready to go?
No.
You're trying to answer the problem.
Oh.
I just want you to write this down. I mean, I'm okay if you give this guy an attempt, but we don't have time for me to come around and check everybody.
I'll just keep doing
Okay? I don't care if you guys want to try to do it on your own, but this one isn't overly difficult. The only reason why I say it's difficult is because that's a transition element, and we seem to forget the rules when we've got these things. Okay? Now notice they told us what the first thing was, which is nice because you guys don't know what hydroxide is. So, PbOH2 as a solid. Yeah? With plus hydrogen monochloride. I gave you the non-acid version of this. It's actually hydrochloric acid. But you guys wouldn't know that either. Okay, hydrogen monochloride would be what?
HCl2 1. No. Yes.
It's mono. Okay. Remember, you don't put diatomic stuff unless it's by itself, right?
Yeah.
Okay. What am I missing here? Aqueous, AQ, which just means that this acid is dissolved in water. To produce liquid water, that's not hard. Plus lead chloride. Plumbum chloride. BB? CL? Why?
Because
Oh, it's ionic. We got a certain method that we have to use, right? Ionic form. 2 plus, 1 minus, crisscross down. Solid, right? There you go. Stay in your seats and I'll pass these out to you quick.
it's not that.
I know it's simple, but it's so long.
Fair enough.
Okay, if you need any help after school, I like to hang out. Someone turn the light on when they leave. Thank you.